Hi everybody, today we're going to move into what's going to seem like a slightly different topic of integration, and you might wonder, well, what's happened to all our finding areas under curves, and it's intricately linked, as I'll explain on Friday. But integration is the opposite process of differentiation. So what that means is, if there's some function, capital F of x, such that the derivative of f of x of this capital F of x equals some other function lowercase f of x, then the integral of f of x is going to equal this original function, capital F of x, plus c. Now, in this case, we call f of x the indefinite integral. Of f of x, and c is a constant known as the constant of integration. So the big idea of integration is that we're finding some function whose derivative will give us this original function. Okay, so the symbol for the indefinite integral is integral, this sign. So we've seen this kind of S symbol for definite integrals, and it's similar to what we use for indefinite integrals. There's just no bounds on it. And this is read as the integral of f of x with respect to x. And how do we know it's with respect to x? Well, that's what the dx tells us. And so then we can also think of it, because it's the reverse process of differentiation, we also can think of it as the antiderivative of f of x. So why is it not just capital F of x? Why is it capital F of x plus c? Well, if we think about if we've got two functions, so x squared plus 3x plus 10, or x squared plus 3x take 2. Now, if we do the derivative, well, the derivative of f of x is just 2x plus 3. And then the derivative of g of x is also 2x plus 3. So we get the same derivative for two quite different functions. And so any value of the constant produces the same derivative. So if we were given a derivative here, we wouldn't know whether it was x squared plus 3x take 2 or x squared plus 3x plus 10. And so then we add in this c to say, well, it might be either. We don't know. So if we don't have any more information, we've got to really just say we don't know. So we just put in this constant term to say, well, it could be any constant term that's taking this place. So then what we say is that the integral of 2x plus 3 is x squared plus 3x plus c. And as we said before, this is called an indefinite integral. Now, some key rules that we've seen before of integration that we're going to use is if we've got a constant out the front, that can be brought out the front, and if we've got two or more terms added, we can just split it up so we can integrate term by term, which is something we used when we were doing differentiation and turned out to be very useful. Now, there are some key rules of integration. So remember, when we're doing integrals, we're thinking, well, what function will differentiate to give my original function? So if I've got a constant, what's going to differentiate to give me a constant? Well, if it's in terms of x, it'll be kx. That'll differentiate just to give me k, and we need to remember plus c. Okay, so if I've got a polynomial, x to the power of n, and we're not going to consider n equal to 1 for the moment. Actually, rather, that's n equal to minus 1. So we're not going to consider x to the minus 1 because that's a little different. But if we're just taking x to the n, well, we knew that when we differentiated, we multiplied down the power and then subtracted 1. So in this case, instead of taking 1, we're going to add 1, and then we're going to divide by the new power. So you might wonder, well, why do we divide by the new power? Why not the old power? Well, if we were differentiating this, it would be the n plus 1 that would come down and cancel with the n plus 1 here, and then we'd just get x to the n. So this would differentiate to give us x to the n. Now, we know that the derivative of e to the power of x is just e to the power of x. So, if I'm going to get a function that's going to integrate to give e to the power of x, then it'll just be e to the power of x plus c. And I should add my plus c to the previous one. It's easy to forget, but it's really, really, really important. Now, what about trigonometric functions? Well, we saw that they have a cyclic nature. So, we saw that sine differentiated to cos, and then cos differentiated to minus sine then differentiated to minus cos, and finally minus cos differentiated to sine. So, what differentiates to give sine? It's minus cos. What differentiates to give cos? Well, that is sine. And then finally 1 on x. So what differentiates to give 1 on x, or x to the minus 1? Well, it's ln x. But we can't take x, we can't take ln of a negative number. So we just have to take the modulus of x, or we can write it as ln x for x greater than 0. So this is inverse function. And so these are our rules. So here I've got a polynomial, so I just got to go term by term. So the integral will equal, well, I add 1 to the power and divide by the new power. So yeah, I'll write out the question first. So 2x cubed plus 5x squared, take 2x, take 1 dx. Okay, so I add 1 to the power, divide by the new power. So adding 1, I'm going to get 4, and it's going to be 2 over 4. So I divide by the 4. Now I add 1 to the power to give me 3, and divide by that new power. Add 1 to the power, so x on its own is just x to the power of 1. So we're going to add 1 to the power, so it's going to be x to the power of 2. Divide by that 2, and then I've got a constant, so I'm going to get 1 times by x, and then I've got to have add c on the end. And so then just simplifying that down, it's half x to the 4, take 5 on 3, x to the 3, take x squared, take x plus c. Okay, alright. Now the second one, we don't have a rule that tells us how, and we're never going to find a rule that tells us how to integrate something divided by something else. So we're going to have to be a little bit creative in what we do here. So first thing I'm going to do to be a little bit creative is I'm going to write this x root x as x to the 3 on 2. That's something we saw back in the first topic, and it's something we used a lot, and it seems we're still using it again. So to continue being a little bit creative, I'm going to then split up my denominator, so it's over each. So each term in the top line is over it. Like that, so I'm allowed to do that, and then I can use my power rules. So the 2 just stays there, then it'll be x to the power of 4 take 3 on 2, which is x to the power of 5 on 2. Then we take, now it's x to the power of 1 take x to the power of 3 on 2, so the 3 stays out the front, and it's x to the power of minus a half, then it's plus 7x to the power of minus 3 on 2. Okay, now we're ready to integrate, because now we can just use our power rule. So if I integrate, so we've got this equaling the integral, so now I'm just going to integrate. So add 1 to the power gives me 2x to the power of 7 on 2, and I'm going to divide by 7 on 2. Take 3, now x to the minus a half, add 1, it would be x to the half, and I'm going to divide by half. Plus 7x, I'm going to add 1 to minus 3 on 2, so it's minus a half, divided by minus a half, and we add c on the end. Okay, so when I divide by a fraction, I multiply by it inverted. So it'll be 2 on 7 times 2x to the power of 7 on 2, so it'll be 4 on 7 x to the power of 7 on 2. Dividing by half is the same as multiplying by 2, so I'll get 6x to the half. And here I'll be multiplying by minus 2, so it'll be minus 14x to the minus a half plus c. We could do some more simplification work, but that's fine for the moment. Okay, alright, now 3e to the x plus 4 sine x. Remember, when we set it back here, we said that a constant out the front doesn't affect our integration, really. So we've got the integral of 3e to the power of x. So the integral of 3e to the x, well, like we know that the constant doesn't affect differentiation, it doesn't affect integration, so we can just think about, well, what's the integral of e to the x? And we know it's e to the x, so that's just 3e to the x. What's the integral of sine x? The 4 at the front won't have any effect, so if we come back here, it's negative cos x. So it's 3e to the x, take 4 cos x plus c. So we don't need to worry about the constant being out the front, we just differentiate, rather integrate normally. Okay, 3x plus 2 on x squared. Now, we don't have a rule that tells us how to integrate if we've got a function inside of something to the power of 2. So, we're going to have to use, again, we're going to have to be creative and multiply out this bracket. So, well, 3x is just going to be 3x squared, which is 9x squared, plus 2 times 3x times 2 on x, so we cancel out the x's, and then it's this last term squared, so it's just 4 on x squared dx. Okay, so we're now looking to do the integral of 9x squared plus 12 plus 4x to the minus 2. And we're going to just use our rules. So first thing I do, add 1 to this power, divide by the new power. I've got a constant, so it's going to be that constant times by x. Here, it's 4x to the minus 2, so I'll be adding 1 to the power to give myself minus 1, and I divide by minus 1, divide by that new power, and I add c to all of that. So this gives me 3x cubed plus 12x plus 4x to the minus 1, and all of that's going to be added to c. Okay, so it's a couple more questions that we've got here, so I'll probably just go through this question 2. So actually that question 2 I'm going to leave for later, so I'll go through question 3. So we're given a second derivative here, and we're asked to find f of x. So I'm going to have to differentiate. So I can say if f double dash of x is 12x squared take 6x plus 2, then f dash of x is going to be the integral of 12x squared take 6x plus 2. So if I'm looking to integrate here, I'm going to add 1 to the power, divide by the new power, and keep doing that. So this is 6x to the power of 1, so that'll be 6x squared, and then it'll be plus 2x, and all of that plus c. So that equals 4x cubed, take 3x squared, plus 2x, plus c. Now, is there a way of determining what c is? Well, in this case, there is. So it says at the origin, it has an equation of 2x, the tangent has an equation of 2x plus y equals 0. So the slope, so we can say that the slope of f of x at x equals 0 is minus 2. So we can think of this as y equals minus 2x. And so we can say that the slope there is minus 2. So we can say, well, what this means is that f dash of 0 must equal minus 2. So I can say that f dash of 0 equals minus 2, which implies that 4 times by 0 cubed, take 3 times by 0 squared, plus 2 times by 0, plus c must equal minus 2. All of these terms are just going to be 0, so it's going to be c equals minus 2. So the derivative is 4x cubed, take 3x squared, plus 2x, take 2. Okay, but now we've got to find the original function, so f of x is equal to the integral of the derivative. So it'll be the integral of 4x cubed, take 3x squared, plus 2x, take 2. And then I go with my adding powers and dividing by the new power. So I'm going to get 4x to the 4 on 4. And that should be take 3x to the 3 on 3, plus 2x to the 2 on 2, take 2x plus c. So these 4's cancel, 3's cancel, 2's cancel. So it'll be x to the 4, take x cubed, plus x squared, take 2x plus c. And then if I go back up, well, when x equals 0, well, we know that the tangent to the curve at the origin, what that means is if it's at the origin, then the function must go through the origin. So we can say when x equals 0, y equals 0, so f of 0 must equal 0. Therefore, we can say that 0 to the 4, take 0 to the 3, plus 0 to the 2, take 2 times 0, plus c must equal 0, so we can say therefore c equals 0. And then finally, to finish off, we can conclude that f of x is equal to x to the 4, take x to the 3, plus x to the 2, take 2x, and c was 0, so we don't need to include it. And that's our final question. Now this example here, we're not going to go through at the moment, so it's not quite relevant to what we're doing just yet. We'll come back to questions like that a little bit later. So your key focuses are back here, all these examples when we use the rules, and when we're given some specific information, we can find C.